God. Okay. All right. The first question should be comparatively easier. There it's stating that the numbers are arranged from 1 to 49. Obviously, it started from here, stopped up to 7. The goal was to fill up the grids and find the numbers which are fitting in those gray gray blocks. And then you can figure out how many of those gray numbers are prime numbers, right? So if I start writing, I'm not going to fill those numbers up. I think you can see it on the screen. The numbers that are going to be fitting in that criteria are 19, 19, 39, 23, and 47. Now, out of that, how many are prime numbers? 19 is definitely a prime number. 23 is one as well. 47 is prime as well. Only 39 is not a prime number. So our answer is 3. Okay. So let's move on to the next question. Okay, the next question is interesting. Let's talk about that. Okay, so NASA Perseverance rover was launched on July 30th after traveling 292, 526, 838 miles, landed on Mars about 6.5 months later. Which of the following is the closest rover's average speed? So as you guys all know, speed is distance over time, right? Okay, distance over time. So you can start rounding things up. So first write this number 292, 526, 838 divide by 6.5 months times 30 days times 24 hours. So this, because your answer is supposed to be in the R, so you are going up to the R. Now, the question is, how do we solve this, right? So now we'll start rounding things up a bit because we are supposed to find the answer closest to that answers. So we will round this up 292, 528, 838 to 300, 300, and 3 more zeros. Divide by, let's convert this 6.5 rounded up to 6. 30 stays as it is. 24, we can round it up to 25. Okay. So with this, let's start getting rid of zeros. So we got 1 0 off. We got 1 3 gone as well. Now 25 times 4 gives you 100. So if we really see this, 4 0 0 0 0 0 divided by 6.
I have a question.
Yes, go ahead.
What happens if you round this 6.5 to 7?
Yeah, that's fine too. I don't think that should be a problem because eventually you will go close to one of these numbers. Because these numbers are so distinct apart, 6,000, 12,000. So even if you come close to any of that number, you can still get the answer. Because
Okay.
everything here in this picture is sort of like a even number. So we are trying to just close to even number as much as we can, but it is okay. Yeah.
Okay.
Times 30 times 24.
Because 6.5 is month converted into days by multiplying 30 days in each month. And then each day has 24 hours. So we have to multiply all these 3 numbers because the answer is supposed to be in the hours. So we are trying to find the time into hours. Okay. So with this, if you solve those things up, it comes down to, it will give you around 60,000 of a 6 36, right? And then you have 401, 2, 3, 4. That gives you 60,000. That's the closest one we can go. So the answer is C. Okay. All right. Let's move on to the next question. This is interesting. More of a equation question. Okay. Along the route of a bicycle race, 7 water stations are evenly placed. So let's make sure that we are constantly, I marked the water 1, 2, 3, 4, 5, 6, 7 in the picture, and they are equally placed. So let's assume that they are like X miles apart. So I have tagged each one of them as X. Now look at further down in the question. There are also 2 repair stations. So let's pick the R1 as a 1 repairing station, R2 as a 2nd repairing station. And they are also equally placed. So obviously they are like distance Y from start, and then between R1 and R2, we also have distance Y, and then further down we have distance Y. So technically, if you see it, like the distance of total between start to finish is 8 times X, right? At the same times, we also have 3 times Y. So the first equation that we can form is 3 times X equals 8 times Y. So that's a simple equation we can form out of this. Now, the next thing, the other fact that we have been given, the third water station, which is this, is located 2 miles after the first repair station. So this is your first repair station. This is your first water, third water station, and they are 2 miles apart. Make sense? So what this means is that 3 times X, meaning this distance, 3X minus Y is 2. So if we solve these 2 equations, oh, I did 8 times X is 3 times Y. So we got these 2 equations. If we simplify them, multiply this equation by 3. So we got 8X minus 3Y equals 0, then 9X minus 3Y equals 6, minus plus minus, this got cancelled, negative X equals negative 6, X equals 6. What are we supposed to find? How long is the race in miles? So race in miles is like 8 times X. Total distance is 8 times X. X is 6. The answer is 48. Yeah. All right. Let's move on to the next problem. Yep, this is interesting. So some of the problems are really interesting in this group of problems. So Nicholas is planning to send a package to his friend who is a stamp collector. To pay the postage, Nicholas would like to cover the package with a large number of stamps. Suppose he has a collection of 5 cents, 10 cents, and 25 cents each, with exactly 20 of each type. What is the greatest number of stamps Nicholas could use to make exactly $7.10 of postage stamp? So the goal is the number of stamps should be maximum. That's key. And the total amount cannot be more than $7.10. Great. So let's start with this. So we have got 5 cents stamps. Then we have got 10 cents stamps. Then we have got 25 cents stamps, right? Now assume that hypothetically for now to start with that person end up using all 20 stamps for 5 cents. The person also end up using all 20 stamps for 10 cents. And let's just add these two together. And let's say we have a question about how many 25-cent stamps that person will use. But the total, we know that it is 700 or 7.10 or 710. So 20 times 5 is 100. 20 times 10 is 200. then we are trying to find out this, let's say x times 25, and then we have 710. So this gives us 300, right? This is 710. So that means this has to be around 410, right? Then only it will add up to 710. Yes. So if you divide 25 times x equals 410, then, and again, that's not the answer, but I'm just trying to give you a view on that. So this gives you 16.54 stamps. And you cannot have a stamp in 0.4, right? It has to be in a full number. So obviously, x equal to 16 is not option, because the moment you put 16 here, 16 times 25 will give you 400. And then you'll be short of 10 cents, right? So 16, 20, 20. 20 is like the number of stamps for 5 cents, 20 cents, and 16 is assume that. So this is number is still falling short of 10 cents short of overall $7. So how do we go about it? Now, the goal is to achieve the count should be maximum, right? So let's try this. Let's take this number instead of 16, let's take 17 of 25 cents. And then let's reduce this by 1. And let's say this is 19. So 17 times 25 will give you 425. 19 times 10 will give you 190. And then let's add these two up. How much it all adds up to? So 5, 1, 615. And we are supposed to go up to 710. So we are short of how much? 95?
Yeah.
95. So 95. Now, how many stems of 5 cents I should do to get 95? That should be 19, exactly. Okay, so if you add those numbers up, 19, 19 of 10, 17 of 17. So this total number of stamps comes out as 19 plus 19 plus 17 equals 55. Okay, now you can, this is the number that you have achieved. And this is one of the answer if you see it on the list, right? But out of curiosity, and that's a maximum, because there is nothing more than 55 in this list. So 55, you have achieved an answer. But if you really wanted to think slightly more, that okay, because my goal is to put more stamps. So if I take 110 stamps out from here and add 5 cents here, the count will go up by 21, but maximum we can only go up to 20 stamps, right? So this is not possible. So that means this is the final and the optimal solution, or the maximum number of count we can achieve out of the total. Prisha, make sense? Do you have that answer? Okay. All right, let's move on to the next question. This is also another interesting question. Vishwam walks half a mile to get to school each day. His route consists of 10 city blocks of equal length, and he takes 1 minute to walk each block. So let's just draw this picture first, okay? So I'll just draw the block, first block, second block, third block, fourth block, fifth block, sixth block, 7, 8, 9, 10. 1, 2, 3. Advika, are you able to follow?
Yes.
Okay. So we have 10 blocks as the question states. And this distance is total 25 mile, 24 point half a mile. So half a mile is the distance across 10 blocks and they're equally placed. How much is the distance between any two blocks? 0.5 divided by 10? 0.05, yeah. Now read the step further down. His route consists of 10 city blocks, equal length, and it takes 1 minute to walk each block. So every time his distance is 1 minute, so he's taking 10 minutes to complete the walk. So far, so good. Now, today after walking 5 blocks, so he was fine moving up to here. There was no issue as such. But the moment he finished the 5th block, he saw a detour sign that says you cannot go on this path. You really have to take a detour. So when he took the detour, he had to walk 3 more blocks. And those 3 blocks were 1, 2, 3. And then he again resumed his journey on rest of the blocks.
Like, it'd be like, not like. But it also is useful. Yeah, so what I thought it is was like, it says walking 3 blocks of equal length instead of 1 block. So I thought it meant like, he takes a longer detour to like, in every single block, instead of the 1 block that he normally walks.
Yeah.
Walk 2 more.
The interpretation could be very different in this case. I agree with you. But because they are just saying block and each block is very squarish in nature. So we just took that idea that the 3 blocks are 1, 2, and 3. Okay, 3 blocks of equal length instead of 1 block to reach the net. Now, in this case, how much, now again, think about the question is saying, from the time he starts his detour, and the detour only starts at this point that I marked as red in this picture, right? What speed in the mile per hour must he walk to reach to the school on time? So that means he took 1 block, 2 block, 3 block, 4th block, 5th block, 6th block, 7th block. So he had to go through 7 blocks, right? And each block is 0.05 miles. So the distance he traveled was 7 blocks. Each block was 0.5 mile. So this was the distance he traveled, right? Now, what was his speed? Look at this. The school he is supposed to reach on usual time. So 5 blocks, he took 5 minutes to cover it. The remaining 7, he has to finish in the same 5-minute time as well, because he has to be on the time, right? He cannot be late. So even though he finished 7 blocks, he still took 5 minutes. So now let's talk about the time. Time is 5 minutes, but now we are supposed to calculate the speed in hours. So we will divide this by 60. That will give us answer in hours, right? Now let's do the math here. 7 times 0.035 is 0.35. Divide by 5, 60 comes up. So we get 12. 12 times 0.35 is 4.2 mile per hour. So answer is B. Are we good? Vedant? Make sense? Okay. Okay, very interesting question. Question number 16. The letter P, Q, and R are entered in a 20 by 20 grid according to the pattern shown below. How many P's, Q's, and R's will appear in this complete 20 by 20 grid? So don't overthink about this problem. Start with simple, first column. So let's start looking at first column. What have we got in this one? So think about, and even in first column, let's start looking at this pattern. So if you just see this pattern of 3 is repeating, right? It'll keep repeating 6 times. Then you get up to 18th row, right? And then there will be 19th row and 20th row for the first column. So let's draw a table here. Column number 1, count for P, count for Q, count for R. So column number 1, I will get, can you guys tell me if I'm repeating this first, and I'm only talking about first column, how many times P will appear? No, it is repeating 6 times, get up to 18. It is repeating.
The other two.
Yes, you got it. It is multiplying 6 times, and then we have 19 and 20. So 19 will get P and 20th will get Q. Make sense, Duty?
Mhm.
So that means we have got 7 Ps, 7 Qs, and 6 Rs. You got it. Okay, let's just do this math for 3 columns, because again, we have 20 columns, right? So we are just trying to find a pattern between initial 3 columns, and then we will extrapolate that information. So second column, Rohin, you tell me how many times Q will appear. Q, this is the first, it is starting with Q, right? It will repeat 6 times, so you'll get Q R P, and then you have Q and P. So Q will repeat 6 times, so that is 6 Qs, right? And then the 19th column will get Q as well. So that means we are going to get 7Q. This keeps. Seven Qs, 7 Rs, and 6 Ps. Good then. Third column, starting with R. So the R will appear in the so talking about the third column, R is the starting point. So R will appear 7 times, 6 times, plus the 19th column will have R and P. So everything P and R will be 7. P and R will be 7, and the Q will be 6 times. Are you with me so far on this? So let's add just these 3 columns and see how many total P's we are getting, how many Q's we are getting, and how many R's we are getting. So if you add these up, you get 20 P's, 20 Q's, and then 20 R's. So far, so good. Now, this you establish the pattern for 3 columns, 18 columns. Oh, sorry, this is the first set you did for 3 columns. This is a set for the initial 3 columns. You got the total number of P, Q, and R in the initial 3 columns is this. If you multiply this to 6, you will get up to column number 18. Yes? So let's multiply this by 6. That will give you 120, 120, 120. So now you have got how many total P's, Q's, and R's you have got until column number 18. Now let's look at the column number 19 and column number 20. 19 is nothing but a repeat of the first column, right? 20 is nothing but a repeat of column number 2. So whatever we have in column number 1 and column number 2, we should simply add those, and we will get the total. So if we add the total number of P's in initial 2 columns, that gives you 13 more. 14 Qs, and 13 more Rs more. And if you add this all together, you will get 133 Ps, 134 Qs, and 133 Rs.
I thought it was like, they showed 25 like boxes.
Hmm?
So I counted them all and then I scaled them up to 200 because it's 20 times 20. No, it's 400. Yeah, but then, yeah, that's what I did.
Do you think it's easy the way we did it this time? Was it helpful? Okay, cool.
I
Um,
need to get something. Can I get it pretty quickly?
yeah, sure. Go ahead. Okay, let's look at this problem. Question number 19. That's the next one in the list. Okay, so you guys learned the area formula in the last class, right? What was the formula for equilateral triangle, area for equilateral triangle? But if you don't know, if you only know the side of an equilateral triangle, the formula was square root 3 divided by 4 times a square. Okay, so you only have been given a side of the equilateral triangle, which is A, A, A. And if you're supposed to calculate the area of the equilateral triangle, the formula is, you can still use half base times height, but then you will have to use the Pythagoras theorem to calculate the height and then multiply it by A and half A times H. So you need to spend extra time to calculate H using Pythagoras theorem. But if you know this formula, that makes the life much more easier and faster. Okay, so let's look at this problem. Should I write this out? So please note down the formula on your sheet so you can, the more you write it down, you will remember it. An equilateral triangle is placed inside a larger equilateral triangle. So the region between them can be divided into 3 congruent trapezoid as shown below. The side length of the inner triangle is 2/3 of the side length of the larger triangle. What is the ratio of the area of one trapezoid to the area of one inner triangle? So let's start making some assumptions here. So the bigger triangle, let's just assume that the length of the bigger triangle is A, and the length of the inner triangle is 2/3 of A, right? Because question is telling you the inner triangle is 2/3 of the side length of the large triangle. So far, so good. Now, the trapezoid form is this. This is one trapezoid, this is second one, and then this is third one. So if you know the area of the bigger triangle, and if you subtract the area of the smaller triangle, what would you get? If you, exactly, 3 trapezoids, right? Exactly. Yeah, so let's try to find the area of a trapezoid first. Area of a trapezoid, obviously 3 trapezoids, is the area of the bigger triangle, which is square root 3 times 4a square. The area of the inner triangle is square root 3 times 4 is duty. Are you able to follow? Okay, cool. So this will give us an area for the 3 trapezoids. Now we are supposed to find the ratio of one trapezoid first. So what is, we should divide it by 3 to find the area of one trapezoid is 1/3 of right? So let's try to simplify a few things if we can. Let's take the square root 3 times divide by 4 is sort of common, and a square is also common. So let's pull this out of the bracket. 1 minus 4/9. And then we simplify this. This becomes 5 over 9 times square root 3 divided by 4a square. So that gives us 5 square root 3 over 27 times 4a square. Let's just keep it to this level for now. Are we doing good? This one? Okay, so this is the area of 3 trapezoids, right? But in the question, we are supposed to find the ratio of 1 trapezoid. So the way we can find 1 trapezoid is divide both sides by 3, right? So we will get the area of 1 trapezoid. Rohin, are we good? Okay, and rest is just a simplification. So this is an area of a trapezoid. The second thing we are trying to compare it with area of a inner triangle. Area of a inner triangle. If you look at in the question, area of inner triangle. So area of inner triangle is, let's just write it. This is the area of a trapezoid. 5 square root 3 divided by 27 times 4a square. And the area of a triangle, inner triangle, is, which is this in the block that I'm highlighting, square root 3 divided by 4 times 2a over 3 square. Are we doing okay? So far, so good? Cool. Let's cancel the square root 3 divided by 4 because it's appearing in both numerator and denominator, just to simplify it. So what we get is 5 over 27 a square divided by 4 over 9 a square. Cancel a square this time. Now we are left with 5 over 27 times 9 over 4. So 9 times 3 is 27. So 5 over 12. So the ratio of these two is 5 over 12, which is our answer number C. Good? All right, let's move on to the 20th question. Okay, the two integers are inserted into the list.
What was the answer above?
The answer is 5 over 12, Advika.
Oh, okay.
I don't know how much you were able to follow. Did you get this?
Yeah, I did. I wrote it down and then I
Okay.
couldn't finish.
Okay. If you want, I can also send you the answer PDF as well after the class, just in case you need that.
Okay, thank you.
Yep. Two integers are inserted in the list of 3, 3, 8, 11, 28 to double its range. The mode and medians remains unchanged. So there are quite a few things in this question. One is that range. You guys know what is the range?
Yeah.
Largest minus
So,
is the range. So that means 28 and 3 are sort of staying as the two largest number. Two largest and the smallest number respectively. Now the mode and medians remains unchanged. Mode means so mode is the number of times a number is repeating, the maximum number of times a number is repeating, so which is 3. At this point, the mode for this question, if I really write this down, 8, 11, 28. So the mode for this is 3 because 3 is repeating maximum number of times, right? And the median is 8, which is this number. And the range so the question says these three numbers should remain the way they are. even though when you insert two numbers in this picture. Okay, so let's start thinking about what can happen, because median is not changing. So obviously, we cannot add two numbers here. If we add two numbers here, the median will shift, right? It has to happen in a linear manner, meaning a one number can go on this side, one number can go on the other side. So we can still keep the median value as 8 without shifting the balance. Okay. So there are multiple cases. Now the mode has to be 3. So one thing we can do is like a case where we insert another number as 3 in this picture. So let's say that let's assume that we are inserting two numbers, A and B, and A goes here and B goes here. Okay, and I will slightly move this up here so we can still keep the median as 8. Okay. Now, one thing that if the question also tells you that the goal is to double the range. The original range value was 25, right? And when you insert these two numbers, your goal is to double the range. So the new range, just write it with a different color. New range should be double of 25. That means 50. We are crumbled on the space, but I hope you just make a star of this one. So you know that the new range value we are trying to achieve is 50. Okay, so we decided with inserting one value in the very initial and the value B at the very end, right? Because it is not shifting the median in that case. And because we also want to keep the mode value same, so that number has to be 3. If I insert 4, first of all, I cannot insert 4 because it will not be in the order. So the only either I can add a number lower than A, which is 2, or I can add the same number. So we are starting with the first case where we are inserting 3 in this picture. So 3, 3, 3, 8 it stays as it is, 1, 11, 28, sorry, not 1, and then B. So now the new range value is 50, right? So let's see, the biggest number in this picture is B. B minus 3 equals 50. That means B equals 53. This is one possible solution, but again, we don't have 53 in the question, in the answers. So obviously that option of, A value as 3 didn't work out that way. Let's look at the second case. Because see, the numbers can be, there are 3 possibilities that you can insert number. One is at the very start and the very end. And the second possibility that we are going to talk about next is the number is somewhere here and here, right? That's the second case. So, and third case is the number is even here, but the A is less than 3. Let's just also talk about that case first. It is not 3, it is less than 3. Okay. But then, yeah, we can still have the less than 3 case. So A, 3, 3, 8, 11, 28, and B. Now, less than 3 is what? Number 2? That's the only thing comes to your mind, right? So let's just say if it is 2, so B minus 2 equals 50 because your range has to be doubled. So your B is 52. So we are going down. We are not going up in this case. You saw the answers are like, yes,
it can be an answer, right? For the first one that we did.
It can be an answer, but there are other possibilities too. So we are exercising all the possibilities. And the thing is, you don't have any 53 in this list.
Yeah, but it says the maximum possible sum.
And it is not at this point, right? That's where we are trying. Oh, okay, okay. I see that way. A plus B is 3 plus 53 is 56. Yeah, that's an option. But let's exercise the other two and see if there is anything. Yeah, you're right. This is 56 is an answer. A plus B is 56. Sorry, my bad. Yes, you're right. Let's exercise. We already exercised A is less than 3. So we got A as 2, B as 52. And if we add A plus B, then we get 2 plus 52 as 54. Do we have an answer 54? No, right? So let's just, we need some space to, we need slightly more space to complete this. Can we add a page? I just want to.
Or just select everything and make it smaller.
Yeah, that's what I'm trying to select this.
It's like,
No, A. Okay,
wait,
Box, I think box is better for this.
we undo it. Okay, and then zoom out so we can select everything. Hi, Precious, that's you.
5:45 a.m.
Yeah, and then just make it smaller.
Okay, I think we are almost close on this question. So let's come back to. Okay, all right. So let's continue exercising our last option where again I'll write this up 3, 3, 8, 11, 28. And this time we are not trying to insert a number here, rather we are trying to insert a number here. Because see, this is our pivot point. So we cannot add anything after 8. It has to be one number has to be before 8. We already tried 3. We already tried a number less. This is the only possibility we are left with, that a number exists between 3 and 4. And the number exists in 1 here. So the number has to be greater than 3 and number should be less than 8. So I think the closest number that comes after 8 is 7. So let's just try this with 7, 3, 3. I'll just put it with a different color. 7, 8, 11, 28, B. And this time, so this is our new number. So B minus 7, the largest minus, not largest minus 7, it is B minus 3 because range is largest minus smallest, right? So B minus 3 equals 50. So that gives you B as 53. And if we do A plus B, A is 7, B is 53. That gives you 60. The goal was to achieve the maximum possible sum of two additional number. So the two additional number will be 7 and 53. And the answer is 60. Now, the question you might ask, like if I do further down on 7 to 6, 5, 4, the sum will be smaller than this, will not be larger because the A is second largest after 8, right? Otherwise, you'll get 59, 58, 54 when you pick 6, 5, and 4. So that's your answer. It was lengthy, but it was interesting question at the same time. All right, let's move on to the next one. Okay. Elena writes the number 1 through 9 on a separate cards, one number per card. You guys can read the question, right? One number per card. She wishes to divide the cards into 3 groups of 3 cards each, so that the sum on the number on each group will be the same. So we are trying to, okay, so first of all, let's see. You have numbers given 1, 9. Now, you guys learned the formula for sum of n numbers. Sum of n numbers is n plus 1 divided by 2. This was our formula when we learned about arithmetic and geometric equation, geometric progression. Okay. So, I mean, you can add those two together as well, but then it is 9, you could do that. But if it is somebody says 99, you cannot do it. So you need the formula for that. So n is 9, n plus 1 is 10 divided by 2. So that means the total sum. Okay, so the sum of all these numbers is 45. She is dividing this 45 into a group of 3 cards, 3 blocks, 3 groups, sorry. So our first group is, let's say, form the first group, second group, third group. The goal is sum of these numbers should be 45. Okay, so let's start with the case, first case. Let's say our first case that we can think about it. So we have 9, 8, 7, right? Now each of these blocks also supposed to add up to 15, because the question is asking, also telling you, so that the sum of numbers of each group will be same, right? The only way you can have this group same when they all add up to 15, 15, 15, that gives you 45. So far, so good. Let's start putting the numbers. Let's put the highest number 987 in the block. Now, how much more I need to add on top of 9 to get up to 15? 6, right? So I can add 5 and 1, right? That like 6, that gives me this. Now on top of 8, I would need 7 more. So I can add 4 and 3. Number 3, that will also give me 15 total. Now on top of 7, I would need 8 more. So I can add 6 and 2. 4 is already gone in the second block, right? We cannot repeat the number. It's a card, only one card in the stack. So this is one combination where you can get 9, 5, 1, 15, 8, 4, 3, 15, 7, 6, 2, 15, and that adds up to 45. Now, the question is asking, how many ways can this be done? That means there are other possibilities too. So let's look at other possibilities as well. Again, let's draw the 3 blocks. Advika, are you able to follow me?
Yep.
Okay. The second case, let's think about it. Let's repeat the same 9, 8, 7. Now, let's start from the others, this side. From this side. So how much we need to add on top of 7? 8 more. And 8, we can get it with 6 and 2 and 5 and 3. 6 and 2 is already done in this case. So let's add 5 and 3. Now 8 on top of 8, we will need 7 more. 7, we can get it with 4 and 3 and 6 and 1 as well. 4 and 3 is already done in the first block. So this time we'll go with 6 and 1. Now for 6 more in the first block, we would need 5. We can have it with 5 and 1 and 4 and 2. 5 and 1 is already done in the first case. So we will add 4 and 2. Right? So if this also adds up and give a unique combination, but with a different flavor of numbers. Now, you can continue exercising this, but I think these are the two combination you will achieve it in the best possible cases.
So you can make more.
You can't make more.
What if you start with one? And give me the number 8, 7. You can do 1, 2, 3.
But then how would you achieve? Your goal is to have 15 on each of these boxes as well, right? If you put all the heavy in the first block, it'll be difficult. It'll be difficult for you to add the other blocks. They'll have more. And secondly, you can only pick 3 cards in the each block. You cannot have more than 3. But if you put 9 and 6 on the first block, you only took 2 numbers, but you need 3. Right? So that 3 cards, 15 total in each box, only gives you these many options. So the answer in this case is C, which is 2. 2 cases. Good. Shall we move on? Next problem. Okay. All right. In the sequence of positive integers, each term after the second is the product of the previous 2 numbers. The 2 numbers. Each term after the second is the product of the previous 2 numbers. The 6th term in the sequence is 4000. Let's start with the first term as x. The second term as y, because everything else after that is started repeating, meaning after the second term, the product of the first 2 terms, that means the third term would be what?
X plus 1. X times 1.
Right? Yeah. And the fourth term would be x times y square. Then x to the power 2 y square, y to the power 3, not cube. Yeah, multiplication of these two. In this case, it was a multiplication of these two. In this case, it was a multiplication of these two, right? So this is a multiplication of this plus this. And then the next term would be x to the power multiplication of this, and this is x to the power 3, y to the power 5. So this is our 6th term. Duty, Prisha, are we good with this logic so far? Now, this x to the power 3, y to the power 5 has the value of 4000 as per the question. And we are trying to find what is the first term. So we are trying to find the value for x. The first term is x, right? We are trying to find the value of x. So we need to do some hit and trial in this question. So let's start with x equals 1. If we put the value of x equals 1, x to the power 3 is 1. Y to the power 5 is 4000. Now at this point, can you think about any number that raises up to the power of 5 gives you 4000? If you think about 10, that'll give you 10 to the power 5. If you take anything less, you can never get a perfect number that is 4000. So y cannot have a value that raised up to the power of 5 gives you 4000. So that is not an option. Let's go with x equal. Let's start the x equals 2. That gives us 2 to the power 3 is 8. Times y to the power 5 equals 4000. So if we divide, oops. Okay, if we divide both sides by 2 to the power 3, we get y to the power 5 as 500. Again, do some logical thinking. can I find a number that multiplies 2 by that multiplies itself by 5 times can give me 500? So that answer is not an option either. Let's try x equals 3. That gives you 243 times y to the power 5 equals 4000. Now, again, this will, if you divide 4000 by 43, you'll get a number in fraction or you'll get a remainder. And that also 3 to the power, oh, 2927. Sorry, my bad. Yes, you're right. Good catch. So if you multiply 4000 by 27, it will not be a full number. And you need to have a full number to get to the power of 5, right? Not a decimal number. So this is not an option either. Let's just go slightly. I'm sure we are coming close to finding the answer. So just hang on to it. 4 to the power 3. 4 times 4 is 16 times 4 is 64 times y to the power 5 is 4000. And again, we had the same condition that it'll also not be a very feasible solution in this case. Now let's exercise 5. 5 times 5 times 5 is 125 times y to the power 5 is 4000. If we divide both sides by 125, we get what? 32. Y to the power 5 is 32. That sounds familiar. 2 times 2 times 2 times 2 times 2. So y is 2 to the power, y is 2. And we can say that since y is 2 in this case, let's put the value of, and obviously x, we already know that here, right? Because we started with x and we ended up in y. So x equals 5, y equals 2 is the answer. And that gives us the value of x as 5. Good?
So instead of like going to each of the ones, what if you go to the answers and see if they work?
Yeah, you can try that one as well. Yeah. Yep, that's good. I like that idea as well.
I mean, the only difference is though that there was a 4 in the answers.
Yeah, you will have to try the 4 times. Like you have 4 options. And you can put those 4 options in this equation as well and see if that meets that. That's valid point. But here also we just did 5. We got the, so either you try those 4 answers or you try the logical way to move forward. Either ways. But yeah, that's right. Yeah, 23rd is another interesting. I think we are just like coming to last 2 questions. So let's quickly finish those as well. Okay, this is the question of probability, right? So the each square of 3 by 3 grid is randomly filled with one of the 4 gray and white tiles. So these are the 4 gray and tiles shown in the picture. I'm sure Duty can easily do that question. What's the answer? So they have given an example. These 1, 2, and 4, I made it in the picture, but they have only given this in the original question. That the goal is to form a rectangle of this. What is the probability that the tiling will contain a large gray diamond? This is a large gray diamond, meaning
No,
I just actually painted it with a different color just to highlight this. So this was like this. Is it okay now? Okay. In one square, a large gray diamond in one of the smaller 2 by 2 grid. So first think about it. The diamond can be here. 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 So there are 4 possibilities. That's why I draw these 4 pictures for your reference. Okay. So just hold on to that thought. Now let's talk about just one picture at a time. In one picture, to make this rectangle in this block, before you put this one thing, how many choices you have got? 4 choices. So in this, the probability of 1 right over total is 1/4. one will fit in, but there are total 4, right? So the probability is what? What is the formula for a probability duty? Or how do you say the probability in a sense? Yes. So how many times it will occur versus total possibilities? So the only one time it will fit in the block, because that's only way you can fit the diamond, make the diamond. But there are total 4 possibilities to put in, right? Now for the second block, the same. For the third block, the same. And the fourth block, the same. So to get one rectangle right, one diamond right, you have 1 over 4 times 1 over 4 times 1 over 4 times 1 over 4. But now you have 4 of these possibilities, 1, 2, 3, and 4. So you will multiply this by 4. Now, if you simplify this, you'll get 1 over 64. That's your C.
Oh, because you get so possible.
Yes. So this one is just for you focused on one diamond. But there are other 4 possibilities in different segment of the same 3 by 3 that can also give you. So you have to multiply this by 4, right? 4 times. Good. Okay, we have come down to the last problem in this list. 24. Yeah. Okay. All right. This, in fact, 2 problems. Sorry, I think there is one more. Yeah. 24. Let's talk about 24. This is very interesting problem. Let's go step by step. Isosceles triangles has equal side lengths. So we know that AB, these are isosceles triangles. So these sides are isosceles in nature and sides are equal. In the figure below, segments are drawn parallel to AC. So this is the segment drawn. This is the segment drawn, and they are not at the same level. So just don't think that they are same level. They are not. They are not. They are not. They are on different heights. Okay. It doesn't matter if it is, you cannot just based on the if the question is not telling you that they are at the same height, you cannot assume that. Okay. Okay. Segments are drawn parallel to AC so that the shaded portion of ABC has the same area. So the shaded portion is this. You see this trapezoid, and the shaded portion is this triangle. So the area for this is same as the area for this. That's the fact that is given to you, right? So we should start thinking about, this is our first clue where we can start this. We can start solving this problem. Okay. The height of the two unshaded portions are 11 and 5. So this is H, total is H. This is 11. From B to this point is 11. From this to this point, it is 5, right? Now, what is the height of is H in ABC? We are trying to find the value of H overall. But what are the facts given? We have 2 facts given. One, that the area of these areas are same. Second, we have these are isosceles triangles, right? Third, the height is H that we are trying to find out. All right, so let's start moving step by step. So the area of a trapezoid. So can we start with the area of trapezoid? Do you guys know the formula for that?
Yeah, base 1 plus base 2 and then
Times height. Very good. And divide by 2 as well, right? Yeah. So let's assume that the side AC is B. AC is B. AC is B as well here. Okay. This is 11, B2, and then the overall is H. So this height is H minus 11. Fair enough? Now, what we don't know, like in the trapezoid formula, we were supposed to know this side as well, because you guys said the half of base 1 base 2 times height. The base 1 is not known, so I assume that I'm putting it as x for now. Okay, and we'll find out the value of x. So area of a trapezoid is half times x plus b times h minus 11. This is a long question, so just keep asking me question if you're not following.
Oh, X is stage
X is this base 1, yes. Okay, now we need to find the value of x. Okay, so we need to apply a similar triangle theorem. The similar triangle theorem states that in a triangle, if corresponding angles pairs are equal, the corresponding angle pairs are equal, which is this and this, this and this. That means if this is, oops, this keeps jumping. Don't want this to jump. If this is H, if this is H1, this is B, this is B1, and this is theorem. So similar triangle theorem. So the ratio of H over H1 is same as base over base 1. You can call this as a similar triangle theorem where the corresponding angle pairs are equal. In that case, the height of a smaller triangle ratio with the height of a bigger triangle is equal to the base of the smaller triangle is to the base of the bigger triangle. We will use this logic to find the value of x in the first triangle. Yep, we'll go next. But did we establish the fact first?
Yeah.
Similar triangle, base ratio, and the height ratio for triangles equals. Okay. Okay, our goal is to find the x. So x over b, we are trying to apply this equation on this first triangle. And then base over base divided by 11 over h. Is that okay? What I have written, is that okay with you guys? X over b, 11 over h. Good. So with this, we can say x equals 11 times b over h. Good. Now, think about it. With this, we got rid of one variable out of the equation. We only have b and we only have h. We have got rid of x in this picture, right?
Oh.
And you guys can keep writing all the steps with me. So, we are not jumping and we are not slowing down anywhere. So I'll simplify this a little bit. So half, I'll pull b out. So we get 11 over h plus 1, h minus 11. And I can also rewrite this as 1/2 h plus 11 over h times h minus 11, right? You can multiply h. Yep. No? So far so good? Okay. This is the, what's that? Yeah, take your time. No rush. I'm not erasing anything. Okay, so we established this fact. Let's just put a block around this. That the area of a trapezoid is this. Now, the second thing is we are trying to find the area of this shaded triangle, right?
In the,
Yeah.
in the third line, the first step.
This
does
one?
it say-
This
yeah,
one?
in the parentheses, does it say H divided by H?
This
Or is
one?
it supposed to be like a B? Like, over here,
Mm-hmm.
but it was H over H.
No, it was okay. So it was this, right? I mean, you saw 11 over H, 11 over H plus 1. It was like this, right? 11 over H plus 1. Let me just write it. This was like this. So how do you simplify 11 over H? You multiply H on numerator and denominator.
Sorry, 11 over H. Sorry.
Huh? We are talking about
Sorry, 11 over H plus.
1. That's what I have elaborated here. This was like this one. It was this. Yes. And I pulled that, zoomed out that step here. And then you can write it as 11 plus H over H. Yes, no, maybe. And this step is sort of, I wrote it down here. Are we good? Shall we move on to the triangle? Shaded triangle? Okay. Let's talk about the area of a triangle, the shaded triangle, which is here. So the area of a shaded triangle is half times base times height, right? And the base, we are, let's say we don't know the base, so let's put x dash times height. Height is h minus 5. So far, so good. Now, x dash, again, we need to use the similar theorem. Let me put a different color on this one. Use the similar triangle theorem in this case. So similarly, we'll have to use a similar triangle theorem here as well. So it will go like this: x dash divided by b equals height of smaller triangle divided by height of bigger triangle. So far, so good. Can we write x dash as h minus 5 times b divided by h? Yes? No? Maybe? What do you guys think? So we found the value of x dash in terms of b and h. That was the objective. Good. Let's further go down. I think we need to just squeeze down on the space. Let's see. Okay, let's continue. Come back to this, come back to where we left off. So we were supposed to find the value of x dash. We found the value of x dash here. Let's put the value of x dash here.
Go back up for a second.
Hmm?
Go back up for a second.
Where?
Yeah. Oh, okay, never mind.
So I'm substituting the value of x dash in the area of a triangle formula. Good. So you got half b over h h minus 5 to the power 2. All right. Now, the question states that the value of the areas of trapezoid and the shaded triangle is same. And the value that we established here was, let me just put it in a different color. The area of a trapezoid was this. The area of a triangle is this, right? Let's put them next to each other. So half of B over H. We have to be very careful with the H plus 11, H minus 11 equals half B over H, H minus 5 to the power 2. So you cancel half on both sides. You can do B over H on both sides. Good? Yeah.
For the h plus 1 times h minus 11. Oh, wait. Oh, okay. It's.
So x dash, the value of x dash was B over H times H minus 5. We substitute the value of x dash here, which is this. And then H minus 5 was the height. Right? So we got half B over H, H minus 5 square. And since the areas of shaded regions are equal, we are putting those two values equal to each other. Good. So we cancel this. What we end up getting is, again, guys, do you guys remember the formula for A plus B times A minus B? A plus B times A minus B.
Is 4 plus
A square minus B
a
square.
square minus.
So that takes this A plus B, A minus B as H square minus 11 square. So all the formulas we learned, we really have to remember those formulas to be able to hit these kind of exam questions in less time. Now, what is left here? H minus 5 square. Okay. Can somebody say the formula for A minus B square? Duty? A minus B square.
A square plus b square minus 2.
Minus 2AB. So H square plus 5 square minus 2AB. That gives us 10H. H square and H square is common on both sides, so you can simply cancel those. And again, space crunch, so I need to move few more things.
For all the questions in AMC, we only have like a minute and a half, right?
Huh?
Average.
For these questions, see, because you are learning this, we are taking more time, but when you do it, you'll do it much faster. So minus 111 square is minus 121, right? 5 square is 25 minus 10H. Let's add 10H on both sides. So we get 10H minus 121 equals 25. Add 121 on both sides. That gives you 10H equals 146. The value of H is divide 10 on both sides, gives you 146 divided by 10, 14.6. Good. The key was that you should know the formula for trapezoid. The key was that you put those values equal. The third thing was the use the theorem of similar triangle and then find the ratio in the proper form so you can get it off that.
That question is
It was long for sure.
this AMC? I mean, yeah, AMC is like put the easier questions first and then the harder at the end.
Well, that's a good question. I haven't thought it from that point of view. It could be.
Like, the first questions were like really easy, they were like graphs and.
Yeah, it could be the case. I don't know, but I cannot say for sure. I'll definitely pay attention to what you said next time if I can find a pattern there. Okay, the last question on the list. Let's just see if we can. Maybe I missed it. Okay. Um, last question on the list. These were the one that I've already did in the for before the class. So I'm just trying to see if I can bring up that question. Okay. Okay. So I'm slightly hesitant of writing all this, so let's do it. 15 integers are arranged. Advika, this is the last question in the list. Are you able to follow us so far?
Yes.
Okay, cool. Last question. Let's 15th integers are arranged in an order on a number line. The integers are equally spaced and have the property that the first value of A1 could be between anywhere between 1 to 10. A2 can be 13 to 20, and the A15 can be anything between 241 to 250. What is the sum of digit A14? So first is, your goal is to find A14 before you can add the digits, right? And you know the formula. I think this is probably the third time this formula is coming in the picture when we almost hit last 5-10 questions. So the nth an is A1 plus n minus 1 times t. And we know that A15 is nothing but A1 plus D, which is a difference of any of those two terms, subsequent terms, A2 minus A1, A3 minus A2, right? Since we are given A2 and A1, so we can just say D is A2 minus A1. Yeah, we don't know A1, but we don't know D either. But we know the fact that we know A1 and A2 in this range. So we are trying to put this whole equation in the form of A1 and A2s and then start doing guesses around A1 and A2s. Make sense? Okay. All right. So A15 is A1 plus n minus 1 times t. N is total 15th term. So n minus 1 is 15th minus 1 is 14. And d is A2 minus A1, right? We know that if there is a equation like 3, 4, 5, 6, so the d is nothing but 4 minus 3, 5 minus 4, 6 minus 5. So d is A2 minus A1. Are you guys able to follow me so far? Okay. So let's start simplifying this equation that we formed. A15 equals 14 times A2 minus 13 times A1.
Wait, why is it 14 times 18?
Because you will distribute this 14 in the bracket, right? So you'll get 14 times A2 minus 14 times A1. And you add one A1 in this list. So you get minus 13 A1, 14 A2. Yes? Okay. Now, focus on this piece specifically. A15 is in a range between 241 to 250. So let's put this equation back again, that A15 is in the range of 241 to 250. Now A15, we already know what it is. So let's replace the value of A14 that we have found here in this list. And this value should be greater than 241, should be less than 250. Yes. Now let's start doing some math. Let's put A2, because see, the value of A2 is also given to you in this equation, right? It is in the range of 13 to 20. Why don't we start with the maximum, which is equals 20? So let's put A2 equals 20 in this equation. So 14 times 20 gives you 280, right? But the A1 can maximum be go between 1 to 10. Yes? So let's take the value of 1 for simplicity, simplified reasons. So 13 times 1 is 13. 280 minus 13 gives you 267. But this 267 is not between 250 and 241. So you cannot have A1 as 1, A2 as 20. Now let's increase the value of A1 to 2. That gives you 13 times 2 as 26. 280 minus 26 gives you 254. Even that is more than 250. So even that is not an option either. Let's try the value of A1 as 3. That gives you 39. 280 minus 39 gives you 241. And 241 does fit in the range that A15 is more than equals to 41 and less than 250.
And there's no other option.
No, let's just keep going. Let's try that a little bit more before we give up. So let's try the A2 as 19. Okay, 14 times 19 is 261. And if you really wonder about, okay, do I need to do all this multiplication? What you can do simply here is 14 times 19 was 280, right? Here you can subtract 19 more here and you get 261. 261, again, put the value of A1 as 1, that you get 13. 261 minus 13 gives you 268, that is higher than 250. It cannot be the case. Now put the value of A1 as 2. 261 minus 26 gives you 255, that is even higher. So see, it is not coming to a conclusion of even putting the value of A1 as 3, you're not finding anything. So you can give up now at this point. Yes.
The first set that you did in blue,
Mm-hmm.
right? So the first one was 280 minus 13,
Mm-hmm.
267.
Mm-hmm.
And in the next set, 261 minus 13 is 268. But shouldn't the second set be a little smaller than the first? Because the numbers are smaller.
Numbers are smaller is, I think A2 is slightly just one less here. Otherwise, A1 is still, we are putting A1, 2, and 3.
Yeah, but I mean the
Oh, you're saying, oh, why this number is higher? Is that what you're asking? Well, you are subtracting an expression. It's not, I won't say there is a very direct correlation in this process. See, in this case, the way A1 is going high, the value of expression is going way farther down, 261, 255 to 222. So I don't know if there is a direct correlation between first set and second set that you can establish. Maybe there is some, but
wait, how is 261 minus 13 260?
oh, my bad. Sorry, you're right. Two, what? Two, did I, yeah, this is 2 is right. 261 minus 13 is, 12 is 48, 249, right? Is 8, 5 minus, yes, 4, 248, yes, 248. You're right. So this is fitting in the list as well.
Wait, what value are they what value are they asking for?
Yeah. The integers are equally spaced and have the property that A1 can be this, A2 can be this, A15 can be this. What is the sum of the digit A14? So for A14, you're trying to find the value of A2 and A1, and A2 and A1 are, did I do this right? 19 times 14 is 261, right? 19 times 14 is
266.
190. 266, yeah. Yeah, I 19 times 14. 19 times 14 is 260. Oh, this one is 266, right? The first one. And oh, this is 20, sorry. This is 266. Minus 13 is 253. Oh yeah, this is 253. Yeah, so this doesn't fit. Yeah, you're right. Good catch. 253. So doesn't fit either. So let's just 260. Yeah, that's 240. So let's
But then like, if it's like that, then we have to go through like 18, 17, 16.
yeah, see, you don't have to go down to that path that often, but I'm just saying you can do that math in your head. This is just we are trying to do very step by step, so you're not missing anything. Basically, I'm helping you to think step by step in this process. But when you do it in your brain, you do it much faster. Like instead of putting these four, you'll just say 280 minus this is this, and minus 13 more than this minus 13 more. You'll keep reducing this by 13 more, and then you will know that, oh, these numbers are not fitting. So that means this is my best option. Okay, so after we have established the fact that A2 is 20 and A1 is 3, we can find the difference between any two subsequent term is 17. And let's go back to A14 formula is A1 plus n minus 1 times t. A1 is 3 based on what we found here. We are trying to find total number of numbers are 14 minus 1 and difference is 17. So based on that, you will get A14 as 2 to 4. And if you add the sum digits, you get the 2 plus 2 plus 4 is 8. Okay. That was